Okay, this is the test for I period. The SPCA collects the following data about dogs they house, which is categorical. Well, age, weight, number of days housed, and veterinary costs all have units and are all quantitative. Breed is the only one that's categorical. Which of these variables about German Shepherds is likely to be normal? Well, weight is most likely to be normal. Cost obviously can be skewed high to the right. Number of days housed, same thing. Ages, that could be multimodal or whatever, but weights are usually normally distributed. If they want to show the trend, they want to show trend. As soon as you see the word trend, you want to think time plot. Okay, box plot doesn't show a trend. It shows a distribution. Bar graph is for categorical data. Pie chart, categorical data. Histogram is for quantitative, but again, it does not show a trend. Veterinary bills are summarized in the ogive. Okay, so you have cumulative percentages on the y-axis. So find where 25% intersects with the x-axis, and that's going to be around 25% will be around 75, and where 75% intersects with the x-axis with the bar, and that's going to be around 175. So it appears that the IQR is 175 minus 75, around $100, and that's the answer. Okay, police ticket at 18 minutes, mean was 72 miles per hour. At 30 women, 64 miles per hour. So you got to weigh the means. So you got 18 times 72 plus 30 going 64. You're going to add these all up, and you're going to divide by 48, and that'll give you your answer. Which is true of the histogram? Distribution is skewed to the right? No, that's false. It's skewed to the left. It's skewed to the lower numbers. It's skewed in the direction of the tail. The mean is smaller? True. We should use a median IQR to summarize this data? True. So the right answer here is 2 and 3, D. 7. The best estimate of the standard deviation of the men's weights. All right, you got 100, 100 of these little dots. You just have to kind of figure that out from the beginning. So over what span are you going to have 64 of them? So you count them in the middle, and you're going to see that 64 is going to go over a span of about 50, 25 to the left and 25 to the right. So the standard deviation is 25. If we want to discuss gaps and clusters in a data set, which of the following should not be chosen? You don't want to use a box plot because it never shows gaps. Histograms show gaps, stem and leaf show gaps, dot plots show gaps. Box plots do not. Now, the next question. This is a trick question. Normal model describes the number of pages a printer ink cartridges last. If we keep track of the printed pages for the 47, now you're not keeping track of how long the ink cartridges last. You're keeping track of how many pages the printers print. That's two entirely different things. There's no way they would be normally distributed. Some printers are going to print a lot, and some are just going to print a little. The histogram will not be will be symmetric. Absolutely not. It's going to be skewed. 95% will be it's not going to be a normal. It's not going to be a normal distribution. You're talking about two different things. The number of pages printed per ink cartridges is not the same as the number of pages put out by a printer. Two totally different things. The answer is A, none. Okay, 10. Suppose the normal model describes fuel economy for automobiles of Saturn as a z-score of plus 2.2. It certainly doesn't have units. It's B also has units, 2.2 times gas mileage, 2.2. Again, C has units. D, well, D doesn't have units at least. Well, no, actually, standard deviation does have units, 2.2 miles per gallon. E, 2.2 standard deviations. Okay, the z-scores do not have units. The only answer possibly could be is E. Okay, 11. A. What is the marginal distribution and percentage of modes of transportation? Okay, so you're going to take, you got the total number of people, employees is 420. Okay, mode of transportation, you got 82 out of 420 that take cars, and you got 126 out of 420 that take the bus, and you got 212 out of 420 that take the train. And then you just convert those to percentages. What is the conditional distribution in percentage of mode of transportation for management? So you go to the management row. There's 90 managers. 26 out of 90, 20 out of 90, 44 out of 90. Convert those to percentages. You get 29, 22, and 49%. You got two variables. Okay, you got marginal distributions here. You're comparing two variables. And so you would need either a segmented bar chart or side-by-side bar chart or side-by-side pie charts. Do they appear to be independent? No. The conditional distribution of management for transportation is quite different from the marginal distribution. So just look at our answers here that we show. Okay, here's the marginal distribution of mode of transportation. And here's the conditional distribution of mode of transportation. They're not the same. So it makes a difference, okay, whether you're management or not in terms of how you get to work. Okay, now book sales. You're taking the number of books sold and converting it into how much a salesman gets paid, which is half 0.50 times each book, and then plus $600 flat fee. Okay. So the mean is affected by both shifting, that's adding $600, and scaling, multiplying by 0.5. So the mean is going to be 640 times 0.5 plus 600, 920. Standard deviation, measures of spread are not affected by shifting. They are affected by scaling. So you're going to multiply it by 0.5 and get 180. The IQR, measure of spread, only affected by scaling, so 0.5 times 450, 225. The max is a data element, so it is affected by both scaling and shifting. All right. The newest employee had a pretty good week among all the people. Her pay Z-score 1.8. What is the Z-score for the number of books she sold? Exactly the same. The z-score is impervious. Obviously, it's no units, okay, and is impervious to shifting or scaling. Cordless phone, where are the phone's outliers? Okay. Now, the IQR equals Q3 minus Q1. Okay. Here, let's move up to cordless phones here. Q3 minus Q1, which is 80. So 1.5 times the IQR is 120. So the right-hand fence equals Q3 plus 1.5 times the IQR, and Q3 is 110 plus 120, which equals 230. Now the max is 200, so the max is within the right-hand fence, so no high outliers. Okay. Now what about low outliers? Q1, well, Q1 is 30. We're going to subtract 230 from that. Clearly, 15 is not an outlier. There are no outliers. Now, one of the manufacturers advertises a cordless phone that is only $31.95, which gets to be a lower price. Well, $31.95, the IQR goes from 30 to 110, and 31 95 is within the middle %, not unusual. Okay, now 14, we're going to label the graph. So the first thing you've got to, here, let's draw the graph. Number of clients per week. You're going to label the graph. You're going to have 3 standard deviations going each way, not quartiles. Okay, so here's 1 sigma, 2 sigmas, 3 sigmas, -1, -2, -3 sigmas. Here's mu, which equals 800, and the units is clients. And the standard deviation is 90, so we got 800, this is 890, 980, 1070, 710, 620, and 530. Okay, and this is 34%, 34, 13 and a half, 13 and a half, 2.35, 0.15, and 0.15. 68%, 95% between -2 and +2, and then between -3 and +3 is 99.7%. Okay, what is the first quartile? First quartile is the 25th percentile, which is -2/3 sigmas times 90, which is going to be 60. So that's 2/3 times 90. So you take 800 minus 60, and that equals 740. Now, another way you can do it, draw the picture. Okay, first quartile, 25%. Okay, we're told that it's approximately normal, 800, 90. So you can use inverse norm. And we're going to use 0.25 because that's the 25th percentile. That's the first quartile. If we put in 800 and 90, then it will give us the data element that goes with the first quartile. So let's get the calculator up here. Let's clear all that. So we'll do second and VAR's inverse norm 3.25, 800, 90. And so 700 and approximately 739 clients is the 25th percentile, first quartile. Okay. Another owner of another gym reports that, okay, this is the extra credit question. Let's go to concrete thickness. All right, so what % of the concrete is under minimum weight? Okay, so we're told that it's approximately normal. The concrete's poured 26 inches, 1.75 inches. So here's 26, and the minimum height is 23. So what's this %? So Z equals 23 minus 26. We're going to find the Z-score, and then that'll help us find the %. Divided by the standard deviation, 1.75. And that's going to be negative 1.71. So we have the Z-score. So now we'll do normal CDF And we're going to do from minus 99 to the z-score, negative 1.71. That's a z-score that corresponds to a concrete thickness of 23. So to negative 99, negative 1.71. And that will be CDF, negative 99. Okay, about 4%. We'll call it 4.4%. Okay, 4.4%. Now, they want no more than 3% of the output to be under the limit. Okay, so what does this mean? So we want the mean to be the same. We don't want to start pouring more concrete because that costs money. So we're going to keep the mean the same. Okay, which is 26. All right. But now they want 23 to only be 3%. Now, the difference between 26 and 23 is still 3. Now let's think about our formula. What does this mean? Well, z equals y minus mu over sigma. So the smaller that z is, the bigger that z is going to get. There's an inverse relationship between the size of sigma and the size of z. So here we got with a standard deviation of 1.75, then a thickness of 23 is going to occur over 4% of the time, 4.4%. So if we want this percentage to go down to 3%, then the standard deviation is going to have to get bigger. Why? Because this standard deviation is going to have to get bigger for the percentage to go down. The bigger the standard deviation, the smaller the percentage in the tail. The smaller the standard deviation, the bigger the percentage in the tail. So we know what z is. We know what we're going to find the z-score for 3%. We know what y is and we know what mu is because 23 and 26 aren't changing. So we're going to solve this equation for sigma. So sigma is equal y minus mu over z. So there's no way to find z other than inverse norm. So we're going to do an inverse norm on 0.03. And then we're going to plug that into our formula, and that'll give us our standard deviation, because we know that y minus mu is negative 3. So inverse norm 3 for 0.03. It's negative 1.88. So we'll take negative 3, and we're going to divide it by that answer. Second answer. Okay, so now sigma must equal 1.595, or about 1.6. Okay, now, what does this mean? What does this mean in terms of the problem? What it means is that the machine must be made more efficient. It must have less variation. That is, it must work more accurately. It probably has to be retooled, maybe rebuilt, possibly even replaced. So whether or not, there's like a trade-off here. It might be more expensive to fix the machine than it is to pour more concrete. So raise the mean. But in this case, all we're considering is decreasing the standard deviation. But in order to do that, the machine must work with variation, which means less variation, which means the machine must be made to work better. That's it for the test.